Hello viewers, welcome to Unacademy, India's #1 online platform for coaching and teaching. Myself R.Vetrivel, Unacademy Physics Plus Educator. Today we are going to discuss SHM, Simple Harmonic Motion, the main concept of simple pendulum and springs connected in series parallel. So these two concepts, the important problem, let us discuss in today's class. So once again, I appeal all the aspirants, those who are preparing for CET, NEET, JEE, Unacademy is the best option for you at this juncture. So use my code Vetrivel Live to subscribe Unacademy. So let us start today's session. First, as we all know, simple pendulum, right? It is an arrangement used, as we all know that, right? Simple pendulum is an arrangement consists of a bob, metallic bob suspended from a inelastic string. Right, energy is conserved during this simple pendulum motion. Right, kinetic energy is equal to potential energy. At the extreme end A and B, potential energy is maximum. At mean position, kinetic energy is a maximum. It is an SHM, simple harmonic motion. Right, here the boppers oscillates in the same path in periodic motion, and its acceleration is always directed towards center, and its acceleration is directly proportional to negative displacement. So then such a motion are called SHM. In simple pendulum, we all know the time period of the simple pendulum, T equal to 2 pi root L by G, where L is length of the pendulum, right? Then, as we all know, seconds pendulum, right? Seconds pendulum whose time period is 2 seconds. Seconds pendulum whose time period is 2 seconds. Spring block system, right? See here, a block of mass M is attached to free end of a massless spring, right? A body of mass M, let mass M is attached to the free end of a massless spring, and which is connected to a fixed rigid support. The spring constant K, right? If you apply the force or if you pull the spring through a certain distance and release it about the mean position, it will move, right, to and fro linearly. So linear SHM. Here the spring movement either left, right from the mean position. So the force applied on the spring is directly proportional to negative displacement, because direction of the applied force and displacement quite in opposite direction. So F equal minus Kx. We know that the linear restoring force, this is linear SHM. Here the spring moves. Once you pull and release it, it will move about the mean position to and fro. Right? So this linear SHM, we know time period T equal 2 pi root M by K. where m is, we know that the mass attached to the spring, k is spring constant. Frequency is reciprocal of time period. You write the time period reciprocal 1 by 2 pi root k by m. This is frequency of spring mass system. Time period of spring mass system, right? 2 pi root m by k. Spring pendulum. We know simple pendulum. Now it is spring pendulum. Right? So you can observe here a point mass suspended from a massless spring. This is, say that a point mass m is suspended from the massless spring that constitutes spring pendulum. From its mean position, just apply the force and pull it through a certain distance x and release it. About the mean position, it will move right to and fro. So SHM. Now when this oscillate up and down about the mean position simple harmonically. So this is vertical simple harmonic motion. The time period and frequency of oscillation are given by time period equal to, we know, 2 pi root m by k, and frequency nu equal reciprocal of time period 1 by 2 pi root k by m. Spring pendulum. Now if the two masses m1 and m2 are connected by the spring, are made to oscillate on horizontal surface. Keep in mind, two masses m1 m2 connected by the spring are made to oscillate on horizontal surface. Then its period will be, time period will be t equal to 2 pi root mu by k, where mu is called reduced mass of the system. The reduced mass is m1 m2 by m1 plus m2. Reduced mass. Two masses m1 m2 connected by the spring are made to oscillate on the horizontal surface. So it's a time period 2 pi root mu by k, where mu is reduced mass system. If the two spring having spring constant k1 and k2 are joined in series, right? Two springs are connected in series. Then what is its effective resistance, right? Two spring of spring constant k1 k2 are joined in series. So you can see that two spring whose spring constant k1 and another spring k2 are connected in series. Then what is the total or effective resistance of two spring connected in series? It will be 1 by the spring constant, effective spring constant in series, equal to 1 by k1 plus 1 by k2. That we can write k1 k2 by k1 plus k2. Now time period of two spring constants, spring connected in series, 1 by 2, see 2 pi root m by k in series. Substitute 2 pi root m ks, we know k1 k2 by k1 plus k2 reciprocal will come up. So this is the formula for time period of two spring connected in series. Now daily test, practice test for Unacademy KCET is absolutely free, is going on. So you can try and attempt the test for free. Now see here, this is the first one. The two springs are connected in series. This is series connection. Now this is parallel. You can see now the two spring having spring constant K1, K2 are joined in parallel. Then their equivalent spring constant will be K1 plus K2. Two spring connected in parallel whose spring constant K1, K2. Their equivalent spring constant will be sum of these two, K1 plus K2. Then their time period will be 2 pi root m by k. K is in parallel, effective. So write it root m by k1 plus k2. Now let us move the first sum. Right? Here is the first problem. Right? So let us go for the first sum. Here it is. A simple pendulum is suspended from a ceiling of lift. When the lift is at rest, its time period t. With what acceleration should the lift be accelerated upward in order to reduce its time period t by 2? G is acceleration due to gravity. We all know here lift is moving upward. A simple pendulum is suspended from the ceiling of the lift. So inside the lift, assume inside the lift, right? If you are standing inside the lift from the ceiling, a simple pendulum is suspended, right? The lift is moving upward with an acceleration a, right? The lift is at rest, its time period t. With what acceleration should the lift be accelerated upwards in order to reduce time period t by 2? We all know time period equal 2 pi root L by G. We know that. When the lift is moving upward with an acceleration A, right? Now lift is moving upwards, right? Lift is moving upward direction with an acceleration A. So then what is the time period become? The time period when the lift is moving upward, T dash equal 2 pi root L by C. Acceleration due to gravity always acting downward, but the acceleration of the lift is upward. So we know that whenever the lift is moving upward, it will be A plus G. Right. So here what is the time period is given in the problem? Time period when the lift is moving upward, T dash equal to T by 2 is given according to problem, right? Now substitute. T dash is T by 2, substitute now. So T dash I can write T by 2 equal to 2 pi root L by A plus G. This is equation 2. Now equation 1, equation 2. Divide equation 2 by 1. Divide equation 2 by 1. T by 2, T cancel. You will get 1 by 2. 2 by 2 by cancel. You will get only G by G plus A. Squaring on both sides. It will become 1 by 4 equal. Root will go. G by G plus A. Cross multiply now. 4G equal to G plus A equal 4G minus G, so it is 3G. So acceleration 3G is the correct answer. Right, option B is the correct one. At what acceleration the lift is moving upward? It is 3G is the correct answer. Yes, let us go for the next question. A girl swings on a cradle in sitting position. If she stands, the time period of the cradle, right, it is given decreases, increases, remain constant. First increases, then it decreases and constant. A girl swings on a cradle in sitting position, right? If she stands, what happened to the time period, right? We all know time period, right? 2 pi root L by G. Here, on standing, what happened? The effective length of the pendulum, right? On standing, the effective length of the pendulum is measured from the point of suspension, right? So the cradle, right? So you are sitting position and then it swings. So when you are standing, what happened? The effective length of the pendulum, the effective length of the pendulum measured from the point of suspension, that effective length will decreases when you get up. When you stand up, the effective length of the pendulum is like a swinging, like swing. Cradle is like a simple pendulum, right? Sitting position you are swinging. When you stand up, the effective length of the pendulum from the point of suspension decreases. So as a result, time period of the cradle decreases. So option A, when you stand, effective length of the pendulum from the point of suspension decreases. When the length decreases, it depends on time period directly. So as the length decreases, so automatically time period decreases is the correct answer. The length of the pendulum executing simple harmonic motion is increased by 21%, right? The percentage increase in time period of the pendulum of increased lengths. The length of the pendulum executing SHM is increased by 21%. We all know time period equal to 2 pi root L by G. Here what is given, right? The length of the simple pendulum increased by 12%. The percentage increase in time period, right? So percentage increase in time period, always we know percentage increase in length delta L by change in length by original length. Percentage increase in time period will be delta T by T, change in time period by original time period. 2 pi constant, leave it, 2 pi constant. This root we can write whole power 1 by 2, right? So here we can go ahead, 2 pi, leave it as a constant. So this I can write, right? L, G also constant, leave it. L whole power 1 by 2. This I can write delta T by T. Change in time period by original time period equal this 1 by 2 power, right, will come first into L, change in length by original length. So keep this in mind. Now what is given here? Delta L increase, see that in length increased by 21%. That means change in length by original length is given 21%. So this is already given in the problem. Okay. The percentage increase in time period is the question. Now use this formula. Percentage increase in time period, delta T by T equals, right, 1 by 2 into what is delta L by L? Delta L by L is 21% is given. That's all. Divide 21 by 2. It is 10.5%. So option D is the correct answer. Right? Yes. Let us move to the next sum. Yes. The time period of the simple pendulum is T. If its length increased by 2%, what is the new time period become? Same, just now we discussed. We know time period is proportional to root L, right? That we can write proportional to, this is 1 by 2. Just now we discussed. So change in time period by original time period equal, this half will come first, change in length by original length, right? Here half into change in length by original length is given 2%. So 2 by 2 cancel, you will get only 1%. Now change in time period by original time, right? Increase in time by, right, original initial time is 1% is given. Now what is the question? Now see that this I can write delta t by t. Delta t I can write new d dash final minus initial change in by original. See delta t increase in time period, change in time period will be final minus initial. Final, let's say t dash. So change in time period I can write t dash minus t by t equal, right, 1%. 1% I can write 1 by 100. Right, that's it. Now you can able to do that. Right, t dash minus t, right, equal t dash minus t equal this t cross multiply t by 100, right, t dash equal t by 100 plus t. This t take it out, you will get 1 by 100 plus 1. Right, what we'll get now, see that 1.01 t, right, 1.01 t option is the correct, right? Directly we can do that. Yes, we'll move to the next sum. Or this directly you can do that. T dash equal t plus 1 by 100, 0.01 t. That's it. You will get 1.01 t. Both are correct anyway. Right? Okay. A body of mass 20 gram is connected to a spring of constant K. Execute SHM with the frequency 5 by pi hertz. The value of spring constant K is the question. A body of mass, so M is given 20 gram. 20 gram is given, convert into kilogram, divide by 1000, 0.02 kg, right? Frequency is given 5 by pi hertz, right? Now we know that time period equals 2 pi by root m by k, right? So time period is given, frequency reciprocal of time period, root k by m. We need to find spring constant k. Now frequency value is given, substitute now. 5 by pi, f equals 1 by 2 pi root k we need to find by m. Mass is given 0.02, right? That's it. Now this pi cancel, 2 cross multiply, right? 5 by, see, pi cancel it, 5 cross multiply, 5 into 2 is 10. So 10 equal this pi cancel it. 10 equal root k by 0.02. Squaring on both sides. 100 equal k by 0.02. Now cross multiply. Right, you will get k equal this 0.02 into 100. It is 2 Newton per meter. So option C is the correct answer. The spring constant value k equal to 2 meter per second. Let us go for the next one. Right? Direct formula substitute frequency, you will get k. Daily 2020 free practice test for Karnataka CET is going on. Attempt the test for free. See here. Right? If K is spring constant connected in series, Kp spring constant connected in parallel, or the effective spring constant in series and parallel combination of the spring in figure. Find ratio of these two, series and parallel. First you see in series one, First diagram you come. These two are in series, K and 2K. Then what is the effective one? Right? 1 by K. First two are in series. 1 by K is equal 1 by K plus 1 by 2K. Right? Take now LCM. This will be 2K. It is 2 plus 1. So that is equal 3 by 2K. That is 1 by Ks. Now what is Ks? Spring constant in series. 1 by K equal 3 by 2. K equal 2 by 3K. Similarly, come to second diagram now. The two spring constant K and 2K connected in parallel. So when these both connected in parallel, the equivalent spring constant will be sum of these two. K plus 2K, that is equal to 3K. That's it. Now go for ratio. Right, according to question, Ks by Kp. Ks is 2 by 3K by Kp 3K cancel, that 3 will come down, so 2 by 3 9. So 2 by 9 C is the correct answer. Ratio of spring constant, series and parallel. Yes, let us move to the next one. Right, and you can see here what is the velocity of a bob of a simple pendulum at its mean position here. Right, this is the mean position, these two extreme position. What is the velocity of the bob of the simple pendulum at its mean position? If it is able to rise vertical height 10 centimeter, right? See, at the extreme position, the bob has potential energy maximum, right? So PE, it is maximum. Here also at extreme position, it has potential energy maximum. At mean position, the bob has kinetic energy maximum. So see that this is the vertical height. See, from that extreme position, how much height it is raised. This is vertical height h. Right, that's only given. Find what is the velocity of the bob of the simple pendulum at here at mean position. What is the velocity? Right, it is able to rise the vertical height 10 centimeter. This h equal to here 10 centimeter. We know here energy is conserved, right? Energy conservation takes place. Kinetic energy converted into potential energy, again converted into kinetic energy. So what happened? The bob possesses kinetic energy at its mean position, which gets converted into potential energy at the height h. But the total energy remain constant. So we can say total energy remain constant mean kinetic energy is equal to potential energy. We know kinetic energy half mv square equal potential energy mgh. Correct? It is oscillating with the velocity, right? V half mv square kinetic energy, potential energy mgh. So both sides m cancel it. So v square equal these two cross multiply 2gh, v equal to root 2gh. That's it. Now root 2 into g 9.8 given already. 9.8 into h is 10. Right, root value take it, you will get right correctly 1.4 meter per second. So the velocity of the bob at the mean position is 1.4 meter per second. Right, it is correct option C. Right, option C is the correct one. 1.4 meter per second. Now let us go for next one. Here it is. A simple pendulum is taken from equator to pole. Its period, time period, what happened? Right, as we all know, right? right? It is equatorial, it is pole, right? It is an equator, it is pole. Simple pendulum is taken from equator to pole. We know distance less from the center. See that pole, the distance is less, so gravity will be more. But at equator, distance is more, so gravity will be less. We know time period 2 pi root L by G. Here T is inversely proportional to root G. Remember, if simple pendulum is taken from equator to pole, acceleration due to gravity increases. As we taken from G, simple pendulum, see T is inversely proportional to root G. As we taken from equator to pole, so the small g value increases. So time period is inversely proportional. So time period decreases. So keep in mind, g increases, pole distance is less. So g value more. So time period and g are inversely proportional. So g increases mean as we taken that simple pendulum from equator to pole, g increases, so time period decreases. A is the correct option. Now see here that resultant spring constant of the system of spring shown in below. See here, first these two K1, K2 are connected in parallel, right? These two connected in parallel. Then the effective spring constant equal to K1 plus K2. We know sum of these two when the two are connected in parallel. Now the resultant will be, now see that these two I simplified. Now both are connected in, this is K1 plus K2. Now it is with the K3. Now these two are in series. Already first you see K1, K2 are in parallel. So effective spring constant equal K1 plus K2. Now these with the K3 are in third spring, no K3. These both are in series. Now what is the equivalent? Now equivalent spring constant equal, both are in series. Direct formula, K1 into K2, right? This is K3, this is you say K dash, right? Now the equivalent spring constant K equal these two, K1, K2, K dash into K3 by K dash plus K3. We know K dash, K1 plus K2 substitute, right? You will get K1 plus K2 into K3, K1 plus K2, see that K1 plus K2 into K3, this is E. Fifth option you will get correctly. Yes, right? Simple, very simple one. These two, first two are in series. So effective will be, first two are in parallel, K1, K2. So effective will be K1 plus K2 sum of, and with the third K3 it is in series. Then we know when both are in series, K1, K2 by K1 plus K2 formula apply. You will get option E is the correct one. Let us go for the next one. Two springs are connected to a block of mass M placed on the frictionless surface as shown in. If both the springs have the spring constant K, the frequency of oscillation of the block is, see that question, try to understand, right? Here the two springs having same spring constant, see K, two spring having spring constant K are connected in series, right? Both are now connected in series connection, right? Their equivalent spring constant, how much now? Both spring constant are in series. Then equivalent will be 1 by K series equal 1 by K plus 1 by K. That will be 2 by K, right? So 1 by K is equal to 2 by K. then Ks equal to K by 2. When these two connected in series, equivalent we got it. Equivalent spring constant we got K by 2. Question is, if both the spring has spring constant K, the frequency of oscillation. Frequency, we know the formula. Frequency equal reciprocal of time period. Frequency of the spring 1 by 2 pi root, right, K by 2m. Why? K by m. But here Ks what we need to substitute? Ks is K by 2 substitute. Right? So keep in mind, first you substitute. Yes. See here. First formula, frequency equal 1 by 2 pi root K by m. Here K is effective, equivalent or net spring constant connected in series. Both are K. So K by 2. That you have to substitute. So frequency equal 1 by 2 pi root Ks value K by 2. So m is there. So 2m. We know that 1 by 2 pi root K by 2m. Option B is the correct answer. Right? So that's the end of today's session. I hope today we discussed simple harmonic motion, mainly the concept of spring constant. When the two spring connected in series parallel, related formulae and concept based problem, plus simple pendulum based on we discussed, right? So we will meet you in the next Unacademy YouTube channel with another new concept. So this is only a free, right? If you subscribe Unacademy, you can able to watch everything, the full chapter, complete PCMB for a single subscription. Use my code R.Vetrivel live to subscribe Unacademy. Unacademy plus course really will help you for your preparation of competitive examination. So with that, we will meet you in the next YouTube class of Unacademy. Myself, R.Vetrivel, Unacademy plus physics educator, signing up from you all. Have a nice day. Thank you.